Welcome back, 8th graders. This is Ms. Parente here. Sorry for my voice. I'm just a little under the weather, but I'm glad to see that everybody's back here, and we're going to start our new unit for this new semester on the first part of our matrix, looking at the sun, the earth, and the moon matrix. Now, this is a new one, taking a further look at the day, the night, and the seasons of the earth cycles. All right, on Earth we have days, nights, months, seasons, and years. This is something that all of us already know, but you can take a look at the pictures and get a better idea of the different seasons. Right now we're experiencing winter. We're all affected by these seasons, but have you ever wondered why they occur? So day and night, let's talk about that. One day, as you all know, is 24 hours long. This is the amount of time the Earth takes to spin around its axis. And you can see the picture there of the Earth spinning in its 24-hour time frame. We experience daytime when we are facing the sun and nighttime when we are facing away from the sun. The sun does not move. As we know, it's a star. It does appear to move across the sky, though, because of the spinning of the Earth. But again, the sun is stationary. It is staying in one place. Just the planet is moving. In the morning, the sun rises in the east, and at the end of the day, it sets in the west. And you can see the picture there showing that representation. So, looking at your matrix, what is the cause of day and night? Why does the Earth experience day and night? Take a look at your choices. You should be able to guess now that the Earth experiences day and night because the Earth spins on its axis. Okay, so let's talk about day length. The length of a day varies throughout the year, and it depends on latitude. Similar latitudes are equal to similar day lengths. This variation or difference is caused by the tilt of the Earth's axis rotation around the sun. Day length at the equator at a latitude of 0 degrees, the day length will be approximately 12 hours. Areas on the equator have a constant 12 hours of daylight all year round, no matter the season that we're referring to. Moving away from the equator, as latitude increases to 80 degrees, the polar circles, either north or south, day length can be seen to increase to 24 hours or decrease to 0 depending on the time of year. So that means that it could be sunny for a full 24 hours or dark for a full 24 hours depending on the time of year in that particular latitude. So that should give you a further idea of how does the length of day change at different latitudes, so to answer the essential question number 2. Okay, so there's some special circumstances that occur at different times of the year. One of those circumstances is called a solstice, and there are 2 times a year that these occur. At 2 points throughout the year, the tilt of the Earth's axis reaches its maximum angle compared to the sun and begins to move back the other direction. This usually happens around June 21st, and we refer to that as the summer solstice, and December 21st, which we refer to as the winter solstice. These days are both known as solstices. On these solstices, that's not easy to say. The rays of the sun shine directly on one of the 2 tropics, as you can see in the picture below. During the June solstice, the rays of the sun shine directly on the Tropic of Cancer. During the December solstice, the sun's rays shine on the Tropic of Capricorn. Another special circumstance that you would see twice a year are called our equinoxes. As the Earth moves around its orbit, it reaches 2 points during the year where the tilt of its axis causes it to be straight relative to the sun. These days are known as equinoxes. You can kind of hear equal in the word equinox, so that should give you an idea of what this is relating to. During these equinoxes, the rays of the sun shine directly on the equator. This happens on approximately March 20th and September 22nd. Okay, so what causes seasons? Now that we know what seasons are and we know why we have day and night, let's talk about seasons specifically. Each place on Earth also experiences seasons: spring, summer, fall, and winter. You can see in the diagram that the sun is located in the center, and you can see that there are 4 seasons located around the sun. You can see that the circular area, elliptical area, is representing the Earth's orbit, or the Earth orbiting around the sun. Again, the sun stays in one place and the Earth moves around on a tilt or an axis around the sun. So depending on what part of the year we are in depends on how the sun is shining on our part of the planet at that time. This picture is showing the seasons in the northern hemisphere where we live. So why do you think the Earth experiences seasons? Okay, again, the seasons occur because of the Earth's tilt, and you can see the picture there. The tilt of the Earth's axis is 23.45 degrees. The Earth spins on its axis. If the Earth did not tilt, we would not have seasons. So the position of the Earth around the sun determines whatever season we are in at that time, depending on your latitude. So, looking at your questions on your matrix, your essential questions, what causes seasons? So what does the Earth, or why does the Earth experience seasons? Take a look at your choices. You should be able to determine that the Earth experiences seasons because of the Earth's tilt. Looking more closely at seasons, in this position it is winter in the northern hemisphere and summer in the southern hemisphere. So if you take a further look at this diagram with me, you can see that the yellow lines represent the amount of energy provided from the sun to the planet on specific areas of the planet. So the top set of yellow lines are pointing to the northern hemisphere, and you can see there's less energy provided from the sun to that part of the planet because the tilt is away from the sun, versus the amount of energy on the southern hemisphere, which you can see the tilt is closer towards the sun. Therefore, it is provided more energy from the sun, which is why it's winter in the northern hemisphere in this picture. This is showing when the Earth moves to the other side of the sun, the northern hemisphere gets more of the sun. Again, the same type of diagram, but it has switched now. So we have more energy coming from the sun to the northern hemisphere. So the northern hemisphere would be experiencing summer at this time. Summer occurs at the part of the Earth that is tilted toward the sun, where there's more direct sunlight. More direct sunlight equals more heat as well. Fall, as the Earth continues to move, fall arrives. The days start getting shorter, meaning less daylight per number of hours. In the winter, winter occurs at the part of the Earth that is tilted away from the sun, where there is more shade. Again, you can see the picture there. Wherever the tilt is pointing away from the sun, that would mean that that is experiencing cooler, probably winter or fall-like temperatures or seasons. As the Earth moves around the sun, it turns to spring. You can see the position here has changed a little bit. The days start getting longer until the amount of daylight and the amount of nighttime is equal. It takes 365 days to complete the seasons cycle, which is what we call 1 year. The northern and southern hemispheres always have opposite seasons. So if we are experiencing winter right now in the northern hemisphere, then the southern hemisphere would be experiencing the opposite, which would be summer. So the seasons occur due to the way that the Earth is tilted. You can see in this diagram. This diagram is showing you what portion of the planet is getting the most sunlight during certain times of the year as it orbits around the sun. So, what season would it be in the southern hemisphere in the following picture? Remember to pay close attention to the angle of the poles and what is pointing closer towards the sun. So you should have answered, if you look at your choices, again, what season would it be in the southern hemisphere in this picture? Your answer should have been winter. Okay, so let's watch this quick video to take a further look at seasons to wrap up what we've been talking about.
Dear Tim and Moby, why do we have seasons? From Jonathan. Good question. We were wondering why spring can't get here a bit sooner. Hey, did you do that? Huh. Ever wonder why globes are made to lean sideways? The Earth orbits around the Sun, spinning on its axis. The axis of the spin is tilted in relation to the orbit by about 23.5 degrees. The Earth's tilt is what causes seasons to come and go as our planet makes its way around the Sun. Without that tilt, the seasons wouldn't change, and it would be about the same temperature year-round wherever you lived. When the Earth is here, sunlight strikes the northern hemisphere directly. That makes the days longer and hotter. We call that summer. Meanwhile, sunlight is striking the southern hemisphere at an angle. The days are short and cold. That's winter. When the Earth is on the other side of the Sun, the seasons are reversed. Right. Tropical places lie on the equator, the border of the northern and southern hemispheres. The tropics get the full heat of the sun all year round, so their temperatures don't change much. The north and south poles are a different story. There's nothing gradual about the change in season in these places. It's winter, then summer without a fall or a spring. Summer on the Arctic Circle means that it's light outside even while you sleep. In the winter, the Arctic Circle is dark all day long. When do these seasons start? Well, here's the schedule for the northern hemisphere. Spring starts with the vernal equinox on March 20th or 21st. Summer begins with the summer solstice on June 21st. The beginning of fall is called the autumnal equinox, and it falls on September 22nd or 23rd. The winter solstice, the first day of winter, happens on December 21st or 22nd. The southern hemisphere begins winter when the northern hemisphere starts summer, and so on. The seasons north and south of the equator are always opposite each other. Ah! You are doing this, aren't you?
Okay, so now that we have sort of summarized what we've just talked about with seasons, let's take a look at the next slide. Okay, the last thing that you have to do is to be sure that you do your action item. You're going to draw the illustration of the Earth revolving around the Sun, being sure to label all 4 seasons in both hemispheres, label the 2 equinoxes and the solstices. Here's an example of what your diagram might look like.